Water helps the environment, and healthy streams will help the environment.
It's like a food chain for real, like without one thing, it leads to another.
Since we don't have a lot of drinkable water, if the streams aren't taken care of, then we ain't got nothing to drink.
A macroinvertebrate is an aquatic organism that is big enough to be seen with the naked eye. An invertebrate means that it doesn't have a backbone. And the reason we care about macroinvertebrates so much is they really give us an excellent window into the water quality of our rivers, lakes, and streams. A lot of people think that you need to have a lot of fancy equipment to go out and test water. The reality of it is that equipment is very important and very helpful, but a really excellent way of assessing the water quality in your rivers, lakes, and streams in your community is to basically just see what's living in them.
Stream health is really dependent on several factors. The habitat is by far the most important, and that isn't just the habitat within the stream bed. It also includes everything that's within what we would call the watershed, and that's any land that drains into that stream. If there's an area that's been completely cleared of trees or grasslands, that's going to affect the entire stream to some degree. If a stream is straightened into a ditch, it's going to be less usable to the species that are there. What you can learn by the community of fish in a stream is certain fish are what we would call indicators of good water quality. And what that means is that certain fish would only live in an area that's very, very clean of pollutants or siltation, because either their insect food would need clean water or their eggs need a very specific water quality. So by finding those fish, you know that it's a very good area. Also, if you only find fish that can tolerate really bad water quality, then that is a big red flag that something's going on in the stream or the watershed. Electrofishing is a form of sampling that we use. A generator produces an electrical current, and then it pulses it very rapidly into the water. And by doing so, it creates a field, and any fish that enters that field will literally be drawn up to the probes where the electricity is coming out, and it will stun them. It very, very rarely is fatal to them. Once we've collected a fish, we will split them into all the different species, and then we'll get weights, lengths if we need to, also check them for just physical health, and then return them as quickly as possible to the stream. There are many different ways that people can help keep a stream clean. Everything from picking up litter that someone else has left behind or the stream is washed down, to just using good land practices or safe application of chemicals on a lawn at the right time of year. These are all things that eventually will help improve stream quality.
Nature cleans water through the water cycle.
It filters it through the soil, like it just runs all the way down, like it filters it through the water cycle.
It goes through a cycle and it's clean.
The main reason that not everybody would use a sewer system is that they don't live close enough to a large city where they have treatment plants. A septic system environmentally is the best way that there is to handle septic waste. It eventually goes out to the soil and works into the nutrients and stuff there, because the soil that was put here on Earth is actually the best filter we have for the septic waste. We have some systems in Indian Hill, it's called drip irrigation, and what they are is an on-site type system. Your sewage comes out of your house into the tanks, it's aerated, and then it goes into a dose chamber, and they have pressure lines that the effluent from the septic is pumped out to, and then it's filtered down through the ground. The advantages of a drip irrigation system is that none of the wastewater leaves your property. Therefore, you're not polluting waterways or having water run off to your neighbors. Mound systems are a little different type of a system than a drip. Your effluent flows to tanks, and then it's usually time dosed or demand dosed to a raised mound system, which is built out of sand and dirt, especially in areas where the soil cannot absorb. And this also is an on-site type system that helps keep the effluent from running onto watercourses. Aeration systems, a type of system that does discharge. If the system has been maintained properly, if you see a pipe that's coming out of a septic system, it's relatively clean, acceptable discharge that can go to a water course, but it's still not the type of thing you would want to drink out of.
Brailleville is on a 300-acre farm located outside the city. Our constructed wetland was a project that we undertook because we had a problem. We had failing septic systems, and failing septic systems pollute. We had a stream that was getting polluted from one of our failures. Septic tanks and leach fields are part of traditional septic systems. We have a wetland in between, and the wetland treats the water to a certain level of cleanliness before it goes into the leach field. The wetland cell is like a big hole in the ground that is only 2 feet deep. It has a liner at the bottom, and it's filled with gravel, and the wastewater goes through this gravel. The microorganisms live on the gravel and live on the roots of the plants that are in the wetland, and they treat the wastewater. The University of Cincinnati and US EPA have been researching our wetland since it was put in. When we put it in, they helped to set it up so that it could be used as a sort of laboratory for experiments. They did a recirculation study where some of the channels were recirculated and others weren't. They were kept as a control to see how much difference that would make to the treatment of the water. A second study involved looking at pathogens. There's a third study going on that has to do with chemicals. Chemicals coming in from medications that people take, from household cleaners, from washing detergents, and that sort of thing. Water is a precious resource. The amount of water on the earth is pretty substantial, but most of that is not readily usable. And as we use the water, we pollute it. But nature has its own cycles for cleaning it up. So we don't want to pollute the water to the point where it can't be utilized. Water is going to become scarcer and scarcer as there are more and more demands on water. And so it's something we really need to care about.
Well, humans have a lot of effect on water.
We pollute it, we do all types of nasty stuff to the water.
Chemical waste and all the stuff people throw in the water.
I don't think we have.
Here in Cincinnati, there's just been a strong interest and a growing interest among citizens and environmental professionals about how we manage our stormwater. The interest is in people being concerned about how we're treating our water systems. And while we have a very safe system, we have safe drinking water, and wastewater treatment systems are excellent, there's a recognition of the environmental quality and preserving the natural functioning of the environment and the ecosystem services that we depend on. And so just having the safe and clean water is not enough anymore. We're moving to where we want to preserve and to restore the natural functioning of the water cycle. The rainwater that falls on our lawns and our roofs and our streets picks up everything in its path. So basically, anything that's on the ground can end up in our stormwater and in our creeks and eventually onto the bigger rivers. The Mill Creek watershed combines parts of Hamilton County and Butler County and contains the entire land area where rainwater that falls on that land will eventually find its way to the Mill Creek and then to the Ohio River.
The city of Cincinnati is so prosperous because it had Mill Creek. All the businesses and industries came in and settled right along the creek so they could dump their waste in there. Originally that wasn't a problem because that's what everybody did, was dump their waste into the streams. But now that we know that that's not a good idea and we know ways to prevent that, there's ways that we can clean up the stream and improve the water quality. The Mill Creek Restoration Project was started because of the long history of abuse to Mill Creek. We were started originally to create an education program for middle school and high school students in the Cincinnati area. And our biggest goal is creating sustainability in the watershed and creating future leaders in the community that can help bring awareness to Mill Creek and help get it cleaned up and improve the water quality. So we have water quality monitoring. Schools will go out in the fall and the spring, and they can compare the different seasons, they compare different sites in the watershed, so they actually do hands-on monitoring with the field test kids. We want to encourage them to learn about the environment and take that with them to involve action taking, so that they're not just sitting in the classroom and learning about the issues, they're involved out in the field, learning about what's affecting their watershed and how they can help it.
Toxic chemicals are still a problem in the Mill Creek, but not nearly as much as it used to be because of the passage of the Clean Water Act in the early 70s. Large industries are no longer discharging the hazardous waste to the Mill Creek that they used to do. What bad stuff is in the Mill Creek? I'd say the number one threat would be high bacteria levels when you have the sewer overflows, because that can ruin your health. Beyond that, I'd say it's the nutrients from fertilizers, because when you get too many nutrients, you get algae blooms and then you get fish kills, and that's a stinking mess. When we go canoeing on the Mill Creek, we'll see kids playing along the creek, and they don't know about the high bacteria levels. They don't know about the sewer overflows. They're just kids playing in the creek. I mean, it's hard to keep kids away from the water. So I feel like that's a really important mission, to at least make it so that the Mill Creek isn't a public health threat.
The problem with the Mill Creek and other urban streams, it's really a matter of impervious surface and what I call peak discharge with rain events. These peak events degrade the streams rapidly, eroding the banks and the bottom, and sandblasting the organisms that live in the stream, just eliminating them from their native habitat on the surface of rocks. In the following leg of a flood event, the sands that are suspended get dumped everywhere and suffocate the organisms and simplify the habitat so that virtually nothing wants to live there.
The Metropolitan Sewer District is on the verge of a very large program to reduce the combined sewer overflows into the Mill Creek. And this is going to be a huge event as far as pushing the Mill Creek to a new level for clean water.
We've had 2 or 3 supplemental environmental programs generated by the current consent decree with the US EPA to stop or curtail combined sewer overflows. And those 3 are a hike and bike trail and river channel improvement. The other one was to eliminate a fish dam at Hopple Street Viaduct so the fish can migrate upriver. And the third one was the removal of a cement bridge causeway below the Western Hills Viaduct. The industrial and natural areas in the Mill Creek are quite obvious to a canoeist. It's the easiest way to see them. The industrial sections are channelized by the Army Corps, what we call a trapezoidal channel. They're about 30-degree slopes on the sides and usually a cement bottom. Very, very sterile, and usually surrounded with old factories that go back in Cincinnati's history. What we're talking about when we talk about natural areas is whether or not we have regrowth of vegetation and riparian zone that allow native organisms to come back to the river. And even in some of the channelized reaches, that goal has been attained. Particularly the lower 1.7 miles of the Mill Creek is an amazing location. There's probably more wildlife there than you'd see in any comparable section of river anywhere because of this compression of habitat. It's an amazing facet of our ecology that what we do on the land, impervious surfaces, pollution, yard waste, everything works its way into the stream, and the stream integrates the quality of our environment more fully than any other aspect. And because what we do on the land impacts the water, the Clean Water Act is moving up onto the land, and it's having impacts now on what we do on land surfaces, as well as what we do with the water we actually take out and drink and put back into the rivers.
I don't think anybody can say they haven't polluted.
Everybody pollutes.
I have never polluted water. I believe I pollute water all the time.
The Federal Safe Drinking Water Act was adopted by Congress in 1974, and what it did was it required US EPA to develop health-based standards that public water systems had to meet. We as a state have adopted those standards as well as other standards, and we enforce the Federal Safe Drinking Water Act law in the state of Ohio. About 67% of Ohioans get their drinking water from groundwater.
Groundwater is the water that we find in the subsurface below the ground. It literally accumulates in large areas we call aquifers. Water systems or aquifers can be very, very large, and it can stretch out into the cities and the villages that we live in. There are several ways that groundwater can be contaminated. It has a lot to depend on what we would call the susceptibility of the aquifer. If it doesn't have a layer of soil that can adequately protect it, then we have to take measures that are more stringent in terms of our overall protection.
Ohio EPA does many different things in the state of Ohio to protect groundwater. We work with other programs within the agency to ensure that hazardous waste facilities, solid waste facilities, air facilities have protections in place to take steps to protect the groundwater so it doesn't become contaminated. We also have a program that works with facilities once the groundwater has been contaminated to remediate the problem to address the groundwater contamination.
We not only want people in communities who are using water from a specific water supply to be cognizant of protecting their water supply, but we also want industries to be cognizant of water supply. Water supplies, especially underground water supplies, if they become contaminated by a man-made contaminant, it may take many, 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 many years for that groundwater to clean itself.
In March of 1951, the Atomic Energy Commission found this small rural area northwest of Cincinnati and assembled 1,050 acres by eminent domain to create a feed materials production center, otherwise known as FERNALD. At this plant, thousands of people worked to purify uranium. This uranium was then sent to other places to create nuclear weapons. Through years of production, making uranium, thousands and thousands and millions of pounds, and hours, contamination creeped into the aquifer through sand, gravel. It was on the soils. Remember, they were production first. There was no environmental movement. And by that way, sitting on top of this aquifer, the aquifer became contaminated. Uranium was underneath the ground in the aquifer. Uranium is a radioactive material. So when it shows up in wells, it could be hazardous to health if consumed in large quantities. The site shut down. In 1989, they said, we are no longer producing uranium. But then what? Okay, now what? We have to clean it up. How do you clean it up? And this was really unprecedented in all of the nation. And it took years of meetings. There were years where we had over 70 public meetings for the citizens, with the help of the community, the government, the regulators, which is the Ohio EPA and US EPA, and even just the fence line neighbors. All those people came together and finally came up with solutions on how we're going to clean that up. Initially, the people were given bottled water to drink until they figured out what was going to go on. The people also eventually got public water supply. Many of the people there were using wells for their drinking water. It was a rural area and that was commonplace. The groundwater supply is actually still being remediated. It's the one last thing that is continuing as far as a cleanup remedy. It's actually a simple process. We have 23 extraction wells. They pull the water up from the aquifer, send it to a treatment plant, and it's simple ion exchange. We can extract the water, pull the uranium out, hold the uranium, and then send clean water out to the river, which is very close, Great Miami River. And the water has to be at drinking water standards, which is 30 parts per billion. It's hard to model out, but it looks like the cleanup could go on to as long as the year 2023. The FERNALD Preserve is a legacy to the people around the area. It's a legacy from the ancient people who were there, the people whose wells were contaminated, the people who fought to clean this place up. And now the FERNALD Preserve is a nature preserve with an emphasis on wildlife. We will continue to monitor it, look after it, take care of the water as long as we need to. But it's a lesson for people that anyone who has an issue in their own backyard can make a difference. And I know that FERNALD was cleaned up to this level because our community got involved. I give them a lot of credit.
Taking baths, showers, washing faces, cleaning clothes, quench our thirst, water the garden.
Brushing our teeth, drinking it, and cooking.
And we use it to wash our hands.
Infrastructure in the economy is sort of like your circulatory system or your bones in your body. They're the support systems that hold it together. And just like your bones and your blood vessels and things like that provide services to your body, the sewers, the water systems, the electric lines, the roads are the infrastructure of an economy, and they allow commerce to take place and for people to move from one place to another, or for goods to move from one place to another.
If we don't have the infrastructure to get water to people and to get waste away from places where people don't want it, then we simply won't be able to expand. And if I'm a company that's coming to Cincinnati and I want a lot of good, clean water, and I want a lot of access to getting rid of waste products, if Cincinnati doesn't have those resources, I'm not going to come here and invest.
Groundwater, rivers, and lakes.
The sink?
I really don't know.
A water recycling facility?
I have no idea.
Don't it come from the Ohio River?
The ocean.
Water is the essence of life. Without clean water or treatable water, humankind would not exist. So the concern for a clean source as well as clean drinking water are greatly related to human existence on the face of the earth. The Greater Cincinnati Water Works is the drinking water utility that provides drinking water to the Greater Cincinnati area and adjacent counties. We have 2 treatment plants. The Richard Miller treatment plant that uses the Ohio River as a source produces about 88% of our production. And then our groundwater facility, called the Charles M. Bolton plant, produces about 12% of our demand. Out of the 140 million gallons a day we treat on an average, probably very little is actually consumed. Most of our water is used for household needs, the flushing of toilets, washing dishes, washing clothes, washing cars. Seasonally, about 2/3 of our water during the summer is used on landscaping and lawn care. 2 big rules that we deal with in the drinking water industry are the Clean Water Act that regulates what's allowed to be discharged into source waters, and then the Safe Drinking Water Act, or the surface water treatment rules, which then regulate how the water must be treated. And one of the groups of contaminants that the water industry is finding, not only in America, but all over the globe, is anything that we humans put in or on our body that is non-biodegradable will come off our body or out of our body into the wastewater systems, where they are challenged to treat these emerging contaminants, where their eventual treatment discharge is into the source waters. Some of the new treatment technologies that are being developed are focusing on these emerging contaminants, as we call them. We are fortunate in the city of Cincinnati that we have the US EPA drinking water treatment facility in town. So we couple a lot of our work with the US EPA. We do a lot of collaborating on projects to define what is the best and most cost-effective way to remove not only the personal care products and pharmaceuticals, but other emerging contaminants that we're detecting throughout the surface waters. The process that is involved in treating drinking water at our surface water plant is removing suspended solids, filtering the water through sand, then filtering the water through granular activated carbon. And at that point, we've removed contaminants you can see and contaminants you cannot see. And then finally, we disinfect the water to assure that nothing grows in the water between the time we finish our treatment process to the time that the consumer receives the water in their house. The Greater Cincinnati Water Works continually checks the quality of water, both with what we call grab samples and doing laboratory analysis. We do about 600 of those a day. Most of the regulations requiring continuous monitoring focus on finished water and what's leaving the plant. But the Greater Cincinnati Water Works has a very proactive approach where we have continuous monitors throughout every step of the process to continually assure that what we expect to see coming out of this process is exactly what we see coming out of this process. Tap water greatly differs from bottled water. Number one, our water is greatly cheaper than bottled water. Number two is we're required to continually check the quality of our water as it moves through our treatment process. One other thing that makes Greater Cincinnati Water Works better than bottled water is that we have no containers. Sustainability is a very important subject that needs to be dealt with today. To me, sustainability refers to the harvesting or using of a natural resource without depleting or permanently damaging that resource. 97% of the water on the earth is salt water, which is somewhat treatable, but desalinization is the removal of the salt is very expensive, and you're left with a lot of salt that has to be dealt with, which salt is a contaminant for drinking water. There's a limited amount of water on this earth. And if we do not continually deplete or permanently damage, we can continually use the water and replace it in a sense as we do. So the water cycle plays large into the sustainability of the water that's available for human consumption.
Treat the water.
Wastewater treatment plants like take all the water from like the sewers and the toilets and stuff and clean it up.
Get it clean as possible.
You'll probably go through like lots of filters or people standing over the reservoir with nets or something.
Make it safe for us to drink.
I think the average consumer needs to care about clean water because water is life and infrastructure makes it happen. And as a public utility, we are responsible to make sure that the adequate infrastructure is in place, treatment processes are in place to not only support the environment, but to make sure that the water cycle is kept intact. Water starts with rain. Most public utilities use groundwater or surface water. Public utilities that treat wastewater, we discharge back into the local streams that ultimately downstream folks are pulling out of to use for drinking water supplies. The Metropolitan Sewer District is monitored by the Ohio EPA, and Ohio EPA obviously has to follow the guidelines of the Clean Water Act, which is promulgated by the US EPA. When you think about all the different types of diseases, hepatitis, diphtheria, all those types of diseases that used to be pretty prominent in the country hundreds of years ago, wastewater treatment actually has been probably one of the most instrumental advances to public health in this country and across the world.
Wastewater is anything that makes its way into the sewer system, the collection system. However, that could be in the form of residential, agriculture runoff, industry discharge into our system, and each one of those brings along either a different challenge or a different makeup of the wastewater coming in. But in general, wastewater can be harmful to us if not treated, and most likely would be harmful.
Greater Cincinnati Metropolitan Sewer District has 7 major wastewater treatment plants and many package plants spotted all through the county. The reason for that is the topography. It's impossible for us to easily get the water to one treatment plant. So we have to put our treatment plants in convenient places so that we can make sure that we're reducing or minimizing the amount of digging and pumping that we have to do to get the wastewater to the different treatment plants. Our major treatment plant is Guest Street, located in the Queensgate area. That treatment plant is roughly 130 average million gallons per day, where our other smaller plants are maybe 1/3 or 1/2 of an average flow of 130 million gallons. The treatment process starts when you flush your toilet. The pipes go down through your home, down lateral lines to the main sewer lines, and those main sewer lines go to larger interceptors, and those interceptors come to the wastewater treatment plant. And that's what we refer to as the collection system. I think it's important to remember that a basic wastewater treatment plant does nothing more than mimic what goes on in nature. We take all of the processes that go on in nature and we sort of reorganize them and restructure them so they're more efficient. Bar screens are a lot like the tree branches that are hanging down in the river. Grit removal is a lot like when you are canoeing on a river and the canoe comes to a dead stop right at the end of the rapids. And the reason for that is the water's slowing down. And that water slowing down allows the scouring to stop, and that grit settles out at the end of the rapids. So all of the things that are going on, all of the settling, all of the biological process, everything that goes on in a treatment plant is happening somewhere in nature. Pretty much the rule should be that if you can't dissolve it in a quart jar in 10 seconds, you shouldn't flush it. But unfortunately, people do. It's a big convenience item for a lot of people. Oils, solvents, paints, gasoline, all that kind of stuff, none of that should go down the sewer in any way, shape, or form. If you have trouble removing grease from your pan that you cook in, it's probably going to get stuck to other things. And that includes the pipes in your house, the pipes going down to the street, the wastewater treatment plant itself. If you're cooking with oils or fats, pour those oils off and put them into a can and throw them in your trash can. It just makes things a lot harder on us and will eventually cost the stakeholder more money. We're not paid for by taxes. We're paid for by your water bill. We're not the people that are creating the problem. Because of the smell around the wastewater treatment plant, often we're looked at as the problem. And instead of looking at us like that, we're the people that are on the front lines, that are making the difference, the ones that are cleaning it up. We're the stewards of public health and the environment. Now, we have our problems, there's no question about that. But I don't think there is any organization that does as much as we do for the environment and for public health.
We do. The taxes and government. Maybe private agencies, like somebody who just really care and they got the money to do it.
I think we pay to keep water clean with our taxes. Well, our parents do.
My mama.
When you build infrastructure, the initial cost is the capital equipment, the pipes and things like that. To simply build it is very expensive. To operate it over time is not as expensive, unless, of course, it's starting to age and has to be replaced.
The majority of our system is probably installed in the 1800s. Some portions are probably approaching 150 years old, so you have to upgrade or replace systems that are no longer able to comply with current law and regulations.
The old sewer system, 100 years ago, what they did was they have used the same pipe to carry the domestic sewage, industrial sewage, and the stormwater. So when there is a storm, all the water gets into the sewer line. So now the volume is much bigger. Now if there's a very big storm, the excess it cannot handle. So what we had to do is we had to put some relief. If there was no relief, what would happen is the street would be flooded with the sewage water. The water will back up in the houses and it will go into the basement. The relief points are basically pipes from the sewer. After a certain volume, it overflows into the nearby water bodies. And that is combined sewer overflow. Sanitary sewer is supposed to be carrying only sanitary sewer. It is not combined sewer where the stormwater can get in. It is only supposed to carry sanitary sewer from the domestic and from the industry. But what happened is, because of the old sewer system, there is cracks and there is decay. If there is a storm or something, water gets into it. And when the sewer system cannot control the volume, if there is too much of volume, again, there is relief point and it releases into the creeks and water bodies. So that is sanitary sewer overflow.
The consent decree that the Metropolitan Sewer District is operating under is a federal court-ordered consent decree that is requiring both the city and the county as co-defendants to address the mitigation of sanitary sewer overflows and to reduce the amount of overflow that is occurring from combined sewers. We are currently negotiating with the federal government as to what plan of action or capital program is going to be necessary to meet the requirements to address the consent decree regulations, and we are working very diligently to do it in a cost-effective way so that we can minimize the impacts of rates to the community. So why are we focusing on stormwater? Because every problem that we have in the system, it is a wet weather issue. Dry weather or average day conditions do not cause problems or overflows in the system.
Out at Poke Run and Sycamore, we're at 5 and 7 million gallons a day as an average. That's an average flow. There's days where at Sycamore, that 7 turns into 50 million gallons coming through the plant in one day. Sycamore's under an extensive construction project. When all the construction is done, we will be able to bring 50 million gallons during wet weather events into the plant and treat it. It was just time to upgrade the facility. There was a flood in 2001 that basically took out all kinds of automation, really messed with the equipment, really compromised the way that we could treat. At Poke Run, we have, and I'll call it a luxury, a water retention basin. And if the flow gets too great to come into the treatment plant with 2 million gallon capacity, we can send water back there for 8-12 hours if needed during a pinch, during a wet weather event. And it actually keeps us from sometimes possibly putting bypass out into the receiving stream. And in this case, it would be going ultimately to the Little Miami River, which is a wild and scenic river, and there's never any good time to put raw wastewater out into a stream.
Why is it so costly for us to deal with the consent decree? Primarily, when you think about the size of our system, we have over 3,000 miles of collection pipes. When you count in the factor that we have certain capture rates in terms of volume that we have to be able to comply with, and the enormous amount of cost that is associated with building storage facilities and also expanding treatment facilities, when you think about the magnitude of our system and the scope of our system and what we're required to do to meet the requirements of the federal consent decree, it is a massive program. And when you think about the cost, we're hoping that that cost will be spread out over a long schedule in efforts to minimize the impact on the community.
The cost of dealing with the infrastructure of a city like Cincinnati is billions of dollars. There's an old adage in economics, the consumer pays for everything. Either the users are going to pay for it through increased fees, or if it's supported by, say, federal or state money, the taxpayers are going to pay for it, and those taxpayers are the users of the system. If I'm a resident or a planner in a city that has issues where infrastructure is aging, I've got a lot of questions to answer and a lot of decisions to make that involve trade-offs. And the trade-offs are, first of all, you can pay for it now or you can pay for it later, because we're in a situation now where prices are going up for gasoline, prices are going up for food, prices are going up for all kinds of things. And now we're asking people to pay more for something that's been relatively inexpensive over the years, just like those other things. And so people are going to make decisions about how they want to use their resources. The planners have to make these decisions in a whole different light. They have to think about the current situation and the future. Really, the trade-offs are now and then, and the trade-offs are, what do I want to give up if I really want to deal with this problem now?
The aging infrastructure issue within a water treatment plant and distribution system are very large concerns for all utilities. We continually replace and repair water mains in the ground. Our goal is to replace about 1% of all of our water mains every year, which when you have 3,300 miles of water mains in the street, that's quite a challenge to continue to keep that up. We continue to develop our storage system where we build water tanks throughout our distribution area. So the way we deal with an aging infrastructure is continually spending capital money to improve that aging infrastructure.
If the waterworks and MSD were in it to make money, they'd do things very differently. But they're not in it to make money. They're in it to provide the service and the level of service that is mandated, and they're really not going to go beyond that. Part of their problem is they have to think beyond it. They have to think of capacity down the road. Our systems are adequate 364 days of the year, and on that one day when we get a lot of rain and everything is soaked, then everything's going to overflow. And if we don't have a system that deals with that one day, then that's when people are really going to be up in arms about the inadequacy of the system. The cities like Cincinnati that are a similar age and a similar size have exactly the same issues, and they're going through the same thing we are. Cincinnati's a bit ahead of the curve because the MSD has sort of taken a lead in studying this system, and maybe it's because we're slightly older than the other cities. But a lot of cities are looking to us as a model of how we're going to do it.
One organization that helps clean the water is the Environmental Protection Agency.
A bunch of water companies. I don't know any names.
Some big place with a bunch of initials.
Orsanco is an interstate agency that was created by a compact in 1948 in Cincinnati. The Interstate Compact is a legal commitment among the 8 states to work together to take and implement a regional approach to resolve problems with interstate water pollution in the Ohio Valley. Orsanco actually has regulatory authority, and that regulatory authority, which is focused on discharges and setting quality for wastewater discharges, is applicable to interstate streams in this district or in this drainage area. Most principally, our efforts have been focused on the Ohio River and the lower reaches of the larger tributaries that drain to the Ohio. Orsanco's job is not to go out in the moon suits, if you will, and clean up the contamination. We are the notification people, and we're the monitoring people. How do we learn about spills that occur? You'll have what might be termed citizen spottings and reports. We can have spills that occur from tank farms or a barge passing by or an industrial installation.
or a mishap at a community sewage treatment plant where they know what's happened and they will obviously report, which they're obligated to do. We operate what we call our spills detection system. There's 15 points along the river and a couple of tributaries, and we monitor the river at least once a day. The Ohio River is a vitally important resource to the nation because of the commerce, because of the some 5 million people that rely on it daily for their drinking water, because of the scope of the drainage area, the economic generator that the Ohio River is.
Dirt, salt, pollution.
Probably toxic waste. Sometimes sewage, if it rains heavily and the sewage plant can't get to it.
When it rains, it takes all the garbage that's on the ground and flows into the river.
I coordinate a hands-on water quality testing program for students who live in the Ohio River watershed, and it's all focused aboard our P.A. River Education Center. It's on a restored, authentic stern wheel paddle boat that we've converted into a fully functioning lab. When students are learning about the water and actually on the water, they can physically see how they use the resource, how plants, animals use the resource. Being immersed in what they're studying makes all the difference in the world because it helps foster those emotional connections that make the Ohio River valuable in their eyes and get them engaged into protecting it. Point source pollution is any source of pollution where we can easily and distinctively trace its source. And contrary to what a lot of people believe, most of the pollution in the Ohio River and in a lot of our watersheds locally come from non-point sources as opposed to point sources. A lot of students come into our program thinking all the pollution in our waterways comes from these big factories belching smoke out with funky stuff coming out of the end of a pipe, and the reality of it is it's more of our activities on land that affect water quality. Well, I think one of the first things students need to do once they're invested is to talk to their parents. I think nowadays, because of all the wonderful environmental education programs we have in and beyond the tri-state area, students are becoming more and more savvy regarding water quality issues and how they affect water quality in their communities. And I think it's a really good role for them to kind of bridge that gap and talk to their parents and families about things that they can start doing just on a daily basis to control their impact on their environment and on the water quality resources, not only in their backyard, but of course the Ohio River as well.
Yes, I care about clean water.
Yes, I do care about clean water.
As long as I'm using it, yeah.
Yes, I do. I love water.
I know if I want clean water, my kids in the future will want clean water.
We started the Saturday Stream Snapshot, which is a citizen volunteer water quality monitoring program, and our idea was to get people sampling in the lower Little Miami watersheds, particularly in places where they'd never collected any water samples, so that we could get a good picture of what was going on with the water quality in the lower Little Miami. And the idea behind it was to have high quality data.
It involves volunteer citizens collecting water samples from streams near their homes, and then they take those samples to collecting spots, and then a group of volunteers at a laboratory in Loveland next to the Little Miami River analyzes the samples for a variety of parameters, always the same parameters, and that way you get a snapshot of the stream's health on the day that you took that sample. And then they keep an electronic database for sake of comparison from month to month and from year to year.
Surprisingly, a lot of people use our data for a variety of things, and we're really honored that Ohio EPA came to us. They're doing a total maximum daily load study in the lower Little Miami River, and they're using our data, which is really quite something. Our data has been used recently by the Little Miami River Partnership to develop a watershed action plan for the lower Little Miami. In addition to that, citizens have used it in hearings for wastewater treatment plants. Even officials trying to track down water pollution problems have come to us and used our data. You'd think that it would be the government's job to keep track of our water quality, and it is, but we have a limited amount of tax dollars to go towards monitoring. And in the state of Ohio, individual watersheds like the lower Little Miami are only monitored once every 10 years. A lot of things can happen in a 10-year period, but by having citizens take responsibility for going out and helping us collect this, we can do it cheaper, and we get ongoing information. So if there is a problem, we find it quicker and we can do something about it before it becomes a real serious problem.
To an extent, I think other people care about clean water, but some people don't really drink water that often.
Not as much as they should.
Well, no, I hope they do.
They probably don't, but I really think they should.
If we can manage the stormwater, in fact, we are at the same time managing the combined soil overflow problem and the sanitary soil overflow problem. We are trying to manage the stormwater in a more natural way. Usually you'll see that all the stormwater goes into the inlet on the side of the street and it just vanishes somewhere in the pipe. But what we are saying is that the stormwater in natural process should be on the surface and stay there and evaporate, or some of it will go in the ground and the groundwater. And in that way it will be filtered, and when it ends up in the rivers and creeks, it will be much cleaner. So that's what we are doing. We are building up a pretty reasonable program in MSD to manage the stormwater using green infrastructure.
The MSD project was a great opportunity for us to be involved. It was a privilege and kind of an honor to be asked to be involved. We've just finished installing a green roof, the first green roof for MSD here within Hamilton County. And that green roof will provide shelter for the building for a long period of time. It will capture the rainwater and reuse it into the plants. It will provide energy conservation, and it will help the building remain cooler in the summertime and warmer in the wintertime. To the owner of the building, it will reduce the amount of energy, typically by 30 or 40%. From a humidification perspective, if you have rooftop units, they take air off of the roof, and so if the air is cooler, it's moister and richer with oxygen, you can't help but think that the indoor air quality impact is going to be enhanced for the building occupants. From a first cost perspective, a vegetative roof is going to cost more in terms of sheer cost. However, when you begin to look at the economic benefits that are transferred back to that design, both in terms of for that particular owner, but also in the larger macro perspective, a vegetative roof actually becomes more cost effective, significantly more cost effective over the long haul. Typically, once you have the roof system installed and all of the growing media and the plants installed and the plants are well established, it tends to be very low, if almost little or no maintenance at all. If you look at the tipping point here in Cincinnati that has started to help drive the vegetative roofing movement, stormwater is one of those major contributors. Vegetative roofs have a huge impact in terms of stormwater retention and reduction. Here in the city of Cincinnati, we average about 41 inches of rain per year. That's about 3.4 feet of rain. A cubic foot of water is 7.5 gallons. If you look at 3.4 feet of annual rainfall, and that equates to 7.5 gallons per foot, that's about 25.5 gallons of water per square foot of roof area that we have to deal with and divert and treat. A vegetative roof typically will absorb and reduce that water from leaving the site by about 75%. If you take the MSD roof, for example, that roof was only about 3,800 square feet. But if you run the math out, that means every year that roof will divert over 72,000 gallons of water from having to go into our stormwater system. And if you figure on 30 years, that's over 2 million gallons of water that won't have to be absorbed and treated, and money spent ultimately to handle getting the water to the treatment location, and then the cost to treat it, and then the cost to put it back into our waterways.
The federal EPA said that cement and steel was not going to be the solution, that we needed a green approach. And that green approach is to attempt to stop stormwater before it becomes runoff. And we do that, we hope, by people putting cisterns on their downspouts that will hold the water during a rain event and leak it out slowly over the next 3 days. We're hoping that they will put in rain gardens that will collect the runoff water from their driveway and let it infiltrate or evapotranspirate so that it either gets into the groundwater or into the atmosphere but doesn't run off the day of the rainfall.
The Rain Garden project is located at our new Green Acres Art Center. We built a brand new parking lot, and this was a terrific opportunity to try to control the stormwater generated by that parking lot. A rain garden is actually a specialized garden. It's bowl-shaped in general, and it's designed for rainwater and runoff to flow into and be trapped for a period of time, in most cases about 24 hours. Rain garden plants are actually the same plants that you might use in your regular garden, but because rain gardens are kind of a specialized application, you use different plants depending on where you're planting them in the rain garden. The very center of it is wet, so you put plants that will survive wet feet for a while in the center. Then you have intermediate plants that like moister conditions, and then on the edges you put plants that like dry conditions. And so if you put the plant in the right place, you can use almost any variety of plants that you can find at a garden center. Rain gardens can be used in a variety of applications. You can use them in residential areas, you can use them in parks, you can use them in downtown areas, you can use them in businesses, you can use them actually at the parking lots of malls. You just have to design it properly so that it has the right inflow, and you have to design it for overflow in case those conditions arise where you have more rainfall and it fills and overflows. But as long as you use the right design criteria to put it in, you can put one just about anywhere. So in Cincinnati, we're trying to promote the use of rain gardens because we want that water, instead of going to a storm drain, to soak back into the ground where it'll recharge the aquifer, and we can use it to keep our own plants green and also to keep our streams filled with water instead of growing dry. So it's win-win for everybody.
Yes, I waste water.
No.
Yes, we waste water a lot. I don't think I waste water.
Yeah, a lot.
Taking long showers, wasting when washing dishes.
Green building essentially is a building that uses environmentally friendly resources and a process to build a building. Green structures will use less energy, use less water, use less resources, and as a result, they will pollute less and are better for the environment. Green buildings will employ common sense technologies in some respects with water. They'll move the hot water heaters close to the source where they're being used. If hot water heaters are too far away, people will turn the faucet on and run a gallon or two of water until the water gets warm. Infrared sensors in faucets. They'll want little Jimmy or Janie to leave the faucet on when they leave the bathroom, so if they stick their hands under and a sensor turns the water on, it automatically turns it off. That'll save waste. Low flow toilets. Toilets use a tremendous amount of water. You can get toilets that use much, much less water than traditional toilets, as well as waterless urinals for men's room. Our homes are similar to buildings. We would want to put in low flow toilets, but we can go beyond that with water restrictors for your shower heads and aerators for your faucets, which will all reduce water, but disperse the water differently so you don't notice the reduced water use.
The Civic Garden Center is creating a green learning station, a learning garden that incorporates many design principles that revolve around sustainability, green roof, permeable pavers, alternative energy sources, and a constructed wetlands for sanitary treatment.
The Civic Garden Center will recycle water through this project by collecting water within the stormwater management system in rain barrels and cisterns, and then utilizing that water to take care of the gardens at a later date when we haven't had rain.
It's sort of like an outdoor science lab where we can test ideas, learn about the environment, and look at the importance of water and energy and everything we do in life.
We chose this project primarily because it is part of our mission to be good environmental stewards. And we believe that conservation of water is a huge portion of being a good steward of the environment. We're really hoping that people who visit the site will be inspired to take some of the technology home. And if they do something, if they do just one thing, like add a rain barrel to their landscape, or not use as much water from the tap, or compost, or garden organically, then we're definitely headed in the right direction.
We can stop the polluting. Once I'm done with the water, turning it off, make sure it's completely cut off.
Turning off the faucet when you're brushing your teeth.
Don't drop anything in the sewers.
Tell people that can make a difference.
Start recycling.
Recycling is taking materials that would otherwise go to a landfill for disposal and sending them through a processing system which separates them and prepares them for manufacturers. Manufacturers then take delivery of these commodities, which usually include glass bottles and jars, plastic number 1 and 2 bottles and jugs, paper products like cereal boxes, junk mail, magazines, things like that. Then the manufacturers will take each item and use it as a raw material to make new and useful products. For our future, it is crucial to start recycling. More than 50% of the items that people throw away today end up in the landfills, and these are items that could have been recycled. Annually, when you use bottled water, if those bottles aren't recycled, it's putting 1.5 million tons of trash back into the landfill. Plastics are made from petroleum, so when you don't recycle those plastic bottles, it takes about 47 million gallons of oil to reproduce new bottles. Everything you put in your recycling bin is made into something new, and when you do that, you're conserving landfill space, you're conserving energy, you're conserving water, and you're doing something very important for the planet. You're conserving our world.
Think about what kind of things you put into the water supply. Maybe changing the types of chemicals you use to clean your home so that you're not putting dangerous chemicals down the toilet. Don't flush medicines and other things down the toilet that are going to the wastewater treatment plant that we don't have technology to treat. Restrict the use of pesticides and fertilizers and other things. Follow the directions. Use them only when you absolutely need them. And then conserve water. The less water we use, the less water we have to treat.
Change personal habits. Research has shown that people can reduce their annual water bill by nearly 30% simply by changing their habits. Doing things like turning off the water when you're brushing your teeth, when you're shaving. Even when you're taking a shower, turn the water on to get wet, turn it off to soap up, turn it on to rinse off. If you use sprinkler systems, make sure you know how to turn off the timer or make sure at least the water is falling on your lawn and not on your driveway. When you run a load of dishes or laundry, make sure you only run it when it's full. Also, put cold water in the refrigerator. Don't sit there and let the tap water run to get it cold. Put it in a pitcher, put it in the refrigerator.
Simple things on a day-to-day basis. You know, if you're doing laundry, a lot of times in the Cincinnati area during wet weather events, we have a lot of combined sewer overflows. So even as something as simple as, hey, maybe I shouldn't do laundry while it's currently raining. And even beyond that, everyday things around the house. If you're washing your car, wash your car in the grass. Minimize any sort of stormwater runoff from your house.
Citizens should really care about clean water because it is liquid gold. 90% of our bodies are water. We can't live a day without it, and we need to have a clean, safe water supply. So water's at the heart of our entire economy, our entire life, and our entire health. And having a clean, safe supply is really essential.
Water is more valuable than oil. Water is more valuable than coal. Water is more valuable than many resources we have. Probably the most valuable natural resource on the planet is water.